Oh, hang on. We might need to mix things up a bit. Ah, I'm sorry. What we're taking in is a string command. So let's refactor a bit more, so we get a few more features out of this guy. Alright. So we have a response, which is a type and an object. I actually want a request to be the same thing. Okay. So far so good. We just need to change one more thing, which is our default strategy. Actually we don't, because it's not really doing anything. Okay, so let's go ahead and build this again. Let's go ahead and fix this. Okay. Let's see how far this gets us. Alright, so we're back in our MudZ project. Let's go ahead and remove that reference. Paste in our new DLL. And add that reference back. Okay. So now we've got an object to work with. So we want to say mudz.core.model.domain. Is it already in our game engine? I had to poke around a little bit. Game request. We're going to cast that to our incoming request.payload. Okay. So we're assuming that whatever we get from the client is going to be of this type. And now that we got our game request, let's see what we did before. It should be very, very similar. In our hive mind, we'll be calling this execute. So we should be able to do core.model.domain.gamengine.hivemind.instance.execute. This is getting kind of long. Game request. And we know that's going to be a game response. And then we can say var response is equal to new response. Payload is equal to our game response. And type is equal to type of game response. Okay. Alright, so what have we accomplished here? So, we have turned our hive mind into a singleton. We've taken this TCP client server thing, and we've extended it so that now it knows how to process our game request using the hive mind. So far so good. Let's go back over to our server. And when we do our async listener, which is our server, it can take in nothing or it can take in a new strategy. So we're going to pass in a new hive mind process strategy. So here what we've done, we've said, hey, I want a new server listening on 1727.0.0.1 on port 4000, and any requests that come in, pass it off to this guy to be processed. And then inside of our hive mind strategy, we know that it's going to take that incoming request, cast the payload into a game request, and then ask the hive mind to execute that game request. And then we're going to take that response, pack it back into a TCP response, and ship it back out. So I know there's a lot of moving parts here, and you can grab the TCP code and play around with it and understand it, and then you can grab the mudz code after this and play around and understand it. And it's going to be one of the easier examples for this idea of sockets and connections. It's going to be really fun to play around with once we get the groundwork in, because whether you're doing Node.js and using Socket.io, whether you go up the food chain a little bit in .NET and you start doing WCF applications, whatever you're going to start using Python and its sockets. We're in that world again where we have all these Internet of Things devices, and in this Internet of Things world, we're back to this network level programming a lot of the time. It's going to be the most efficient and the fastest. The web world it's one of many ways to consume things these days. Okay. So, what do we need next? So we got our server all wired up. And what happens if we come down here and we say mudz server? Let's try to build it first before we get egg on our face. Hive mind has no constructors defined. That's fine. This is going to be some old stuff from our old way of doing things. We're going to rectify that in a minute, but just to get rid of the error, we'll say hive mind.instance, right? Because that's our singleton. Now, as a point of note, it's only going to be for this app domain. So main is our app domain. So we're going to ensure that we only have one version of this for this program. Let's try to build again. One succeeded, no warnings, feeling good about ourselves. Okay, so go back down to our server, and let's go ahead and debug it. Okay, so far so good. It's working. Our mudz server is up. This is very exciting. Hang on. We've successfully taken the game we wrote in 6 weeks last time, well, 7 or 8 really, and we've attached it to a TCP server. So if we had a client, which we will in a second, we'd be able to talk to this server. Multiple people could talk to this server and start getting responses back. And we are just a stone's throw away from, if we really wanted to, throw this thing out there on the internet someplace with a public IP and start getting some people bouncing around inside the game. So, from scratch, we're doing pretty good. So if you ever thought that building a game and building a TCP server and a multiplayer thing was beyond you. It is not. Okay. All right. So that was our server and all its two-line glory. Let's come back over here to our. This is our console app, right? This is what we were doing before. So if we just debug that, still looks the same. Our Singleton's doing its job. We didn't break anything, and we can still. Let's fight Carl. Did I say git? I feel like I said git before, and it's yeah. I thought we had a. There we go. So I didn't two-string all of our commands, but I can. Gary takes test hammer and quickly hides it away. Get test gloves. All right, so all our stuff is working. Sorry, no command match your request. Let's try one more thing, just to make sure everything is kind of as we know it to be. All right. Okay. So I can do everything until my stamina runs out, and then I'm just laying here. Okay. So doop. We want to take this and turn it into a client. What did our other client look like? Can we do that easily? We might not be able to. Alright, so other client had a default render strategy. Very similar thing. Let's go take a look at that. So in the same way that our server took the request and handed it off, we're also handing off something. Oh. So we're assuming this thing's going to be a string that we get back and not a game response. And then we're writing it out. That's our default. But how do we ensure, hang on real quick, how do we ensure that we're going to be sending what we want to be sending? We might need to do a little more work. This might be some work for tomorrow. Really digging in here. So we're just reading the line and we're sending it off. It's just a string. Interesting. Do we want to do that? Do we want to have the server interpret just a string? Or do we want the client to be in charge of that? I'm stroking my beard in concentration. Because right now I'm reading in a string, I'm reading in the line, and I'm sending it out. Let's extend some stuff. So instead of client, we've got our client, we've got render, let's add a new folder called parse. I'm going to say new item. No. Am I debugging? Strange. Alright, new item. Make an interface. We call it the iParse strategy. Make that a public interface. So we want our client to be able to do two things. We want our client to be able to take in something, turn it into a request, and then send off the request. And we also be able to render the response that comes back. So we have a render strategy here, and all it does is say void